Our first project was a traditional ballistics pendulum where we took a BB gun and shot a piece of clay and calculated the angle in which it moved as well as how high it moved, and we used that information to find the velocity of the BB gun.
It hit.
Okay, so we're going to be calculating the velocity of the bullet using two lenses. One is momentum and one is energy. So for momentum, we know that m1 v1 plus m2 v2 equals m1 plus m2 times vf, since these two stick together because it's an inelastic collision. To find vf, we're going to use the lens of energy. So we know that the distance that that our structure moves up, delta H. Okay, well, we know that the kinetic energy given by the bullet at the bottom here is equal to the gravitational and potential energy 2. So here it has kinetic energy, and then here it has potential energy. And we know that all of this kinetic energy is transferred to potential energy because energy is conserved. So we know that this is equal to 1/2 mv squared equals mgh. And this is the delta h that it moves up. However, we know that the m's here are going to be the same. They're going to be the mass of the bullet and the clay together. So that's equal to 1/2 m1 plus m2. And this is the final velocity that we use here. I really don't think I can explain this well. Alright, so we know the masses cancel. We solve this like an energy equation. We know that Vf equals the square root of 2g delta h. And we found delta h here. So we just plug in the numbers. We know that delta h is equal to 0.25 just from measurements. And then we have Vf is equal to the square root of 2 times 10 meters per second squared times 0.25 meters. And we have this calculated. So if you do that calculation, we find that the final velocity of both the masses together is equal to 1.04 meters per second. Wait, now that we have the final velocity, we can use this momentum equation to figure out Vi. So if we rearrange this equation, we have, can you see over here? Mm-hmm. We have V1 is equal to M1 plus M2 Vf. And this whole thing we can disregard because it's equal to 0, because we know that the initial velocity of the clay is equal to 0. So this whole term gets dropped out. So we have M1 plus M2 over Vf times Vf over M1. Then we just plug in numbers. So V1 equals, we have M2 over here, M1 over here. So we have 2.05 times 10 to the negative 2 kilograms plus 1.417 times 10 to the negative, oh, this is 4. 4 plus 10 to the negative 2 kilograms times final velocity 1.04 meters per second, all divided by m1, which is 2.05 times 10 to the negative 4 kilograms. And if we calculate that, we get that the initial velocity of the bullet is equal to 72.9 meters per second.
Our second project was a little different type of ballistics pendulum where we didn't measure the change in height of a mass, but rather we measured the difference in point of impact of the BB on two different rotating discs. 3.
So we are calculating the velocity of the bullet again using a different mechanism. So we're trying to find the velocity, and we know that velocity is equal to delta x over delta t. We have delta x, we know the distance between these two disks, and we're trying to find delta t. We know that omega is equal to delta theta over delta t, the change in theta over t. So we could rearrange this equation to have delta t is equal to delta theta over omega. We found omega by knowing that we have the iPhone camera has 120 frames per second. It took 4 frames to turn once around. So 4 frames divided by 120 frames is equal to 0.03 seconds. Omega is equal to delta theta over delta t. And since delta theta is turning once around, delta theta is 2 pi radians divided by 0.03. So we know that omega is 209.43 radians per second. Alright, so once we have omega, and we have the change in theta over here, which was 37 degrees, we put that into radians because we know that 1 radian is equal to about 57 point something degrees. So we converted that to radians, so we know that this is equal to 0.65 radians divided by 209.43 radians per second. This turns out to be about 0.003 seconds. And then we can plug that t back into this velocity equation that we have. So we know that velocity is equal to, this is a given, 0.19 meters divided by 0.003 seconds, which turns out to be about, what was it, 63.3 meters per second, which is pretty similar to our other velocity, so we're happy. God, I love physics. Don't you just love physics?
You don't have to what?
How could anyone not love physics?
I know. I mean, we did a little bit.